Yes. You can continue. Like start.
Okay. Uh, this is our last module, guys. We are gonna wrap up that with this. It's not a very long module. Probably should take about an hour uh, with the concepts. So the fourth module is statistical methods in quality management. So what is it? Why do we need it? Basically, in today's data-driven world, uh, stats and using statistical techniques on our data, it will help us to make optimal choices when when there are decisions to be made under uncertainty and risks. So we will develop this. We will use probabilistic models and statistical data and such methods for sums to come and make optimal decisions. We'll firstly begin with t-test, which was there in term one as well. But don't worry, I'll be going from ground up. We'll cover basics, then we'll start with the sum. I believe you all can see my screen.
Yes.
Yes, sure.
Okay. So this is our first sum. For faster operations, an airline has implemented an automated baggage check-in policy for the frequent flyers in the domestic circuits only, which allows the passengers to directly drop their bags if the weight of the luggage is less than 20 kgs. However, the airline it suspects that some of the passengers are trying to take advantage of this policy and are trying to check in heavier bags without paying, the extra baggage fees that the airlines charge. To investigate, a random sample of 40 bags is tested and the following data is recorded. The sample mean weight of all the bags that were tested, of these 40 bags that were tested, turned out to be 21.2 with standard deviation of 2.5 kgs. So, standard deviation is how much of the total observed weight of all of these 40 bags is different from the sample mean weight, which is given here. So we have to find out using hypothesis testing at 1% level of significance if the airline has something to worry about. And we will also cover type 1 and type 2 errors. So we'll begin with laying out a hypothesis. Our null hypothesis is that mean bag weight is 20 kgs, which is what the policy intended. But what we are trying to investigate is that the mean bag weight exceeds 20 kgs. Because, however, the airline suspects that some passengers are taking advantage of this policy and checking in heavier bags. That is what we are testing, and that is what the airline is also trying to determine. So, let me. This was the formula that we used to use in our first semester, if all of us had. T is what our t test is. That is our variable. X bar, which is the mean given here, the mean weight 21.2 kgs. Mu is 20 kgs, which is what our policy intended. Standard deviation given was 2.5. N is nothing but our sample size, which is 40. So we'll write those down again. So this is called mu. Any 2.5. is 40. So our T, that would be 21.2 minus 20, and we'll divide it by 2.5, which is further divided by root of 40. Alternatively, you could also write it as root of 40 multiplied by 21.2, 20, the whole divided by the standard deviation, 2.5. Because this was just another part of the denominator which should be carried up to the numerator. A t statistic value that would come out to this is just a different calculator. Can you see a calculator on the screen actually?
No.
Okay. So I'm just using a standard inbuilt calculator, which is there in every laptop and all of the screens that are. So for obviously for the exam, we would get the TCS calculator, which is the same thing, just in a different form. So our value comes out to be 3.04. Now, if you'll recollect, we had been given 1% level of significance. So that is nothing but a alpha, 0.01. And again, let me introduce to you the concept of degrees of freedom. For t-test, the degrees of freedom, it's just n minus 1. So here we had a sample, n is sample, which is 40. So here our degrees of freedom would be 39. So we'll go back to the t distribution table. We'll look for these two values. I'll explain, don't worry. So in the table for student t distribution, the first column again is the degrees of freedom, and we look for the alpha value with which we are testing. So for degrees of freedom 39 and alpha value of 0.01, our value comes out to be 2.46. So So our T critical value, which we got from the alpha and the degree of freedom, it is 2.46. And our T test statistic value was 3.04. So what do we do when our T statistic is greater than the T critical value? In this case, H0 gets rejected if our T value is greater, if our T statistic is greater than the T critical. So, hence we reject our null hypothesis. In this case, it meant that the mean bag of the weights was 20 kg. So, airlines has airline has to worry about breach of policy, or however the question is put, or however we are faced with the options. That's our first sum. And this would help us because if the airline doesn't charge appropriately to the customers for if they have a baggage limit of 20 kg, someone comes with higher baggage, that's how they basically earn, right? One of their sources for income. So if they wouldn't charge, they would suffer because extra weight that requires extra fuel, that would also require the airline to spend more money on all of the fuel and more measures, which obviously is relevant to the airline industry. But if they don't, they run out of revenue. Who knows how it would affect their future performance. And that is why we use the T test for uh, management and finances in particular industry. That's our sum. First. Does anyone have any doubt?
Yug, what is this type 2 error?
Okay. Yeah.
You zoom the X a little bit, like it is not visible, like
I mean, so far, does anyone have a problem with what we have solved? I'll come to type 2 and type 1 error. But before that, if anyone has any
I just have
problem,
this doubt that how did we get to know that we have to use t-test here?
we have been given a level of significance. We have been given a sample mean weight and a standard deviation. And we haven't been asked to calculate upper and lower limit. That's why.
Okay.
Then should we go to type 1 and type 2 errors?
Is it a standard fact that we have to, when T statistic is greater than the critical, we should always reject the null hypothesis, right?
Yeah, it is.
Okay.
एंड chi square में बिल्कुल opposite होता है ना? If the critical value is lower, if your statistic value is lower than your critical value, you accept null hypothesis.
Yeah.
ठीक है.
Okay. So type 1 error and type 2 error. Type 1 error is nothing but, if I had to put it, it would be like false positive. What I mean is, suppose here we rejected the null hypothesis, right? But in case there were some situations which told us that the null hypothesis is actually true. Like suppose if the sample of 40 bags, instead of these 40 bags, we had a sample of suppose 400 bags. And our T statistic value was lower than the T critical value, and still we would have rejected by some or the other error. maybe in calculation, maybe we just forgot this rule. And in that case, when we would have rejected the null hypothesis instead of accepting, then it would have been a type 1 error.
Bhai, is it just me or is everybody getting kicked out?
That should maybe the settings like last time. Need to
Yeah,
be
I
changed.
was changing, like someone also said like he is kicking out every time.
My first meeting में मुझे भी निकाल दिया था ऐसा है.
Yeah.
Okay, coming to type 2 errors, it is when we accept or when we fail to reject the null hypothesis, then it is actually false. So supposedly when I said that the mean weight of bags is 20 kgs, but then if you would observe the actual weight of the bags, then all of them turn out to be, or statistically majority of them turn out to be over 20 kgs. And I say if it's less than 20 kgs, then that's a type 2 error. So that arises when we accept H0 when it's false. Accept.
Ayuk,
Yeah,
in this question, will we apply that something right tail t-test, or because there is only one thing that it exceeds 20 kg.
we apply one tail.
One tailed, right?
Because this is uh, m is equal to 20 and this is m greater than 20. Hence it's a one tail. Sorry, less than equal. Any problem so far?
Yog, someone in the chat is asking that the conditions for chi-squared test and t-test are same and opposite for Wilcoxon, right?
Yeah, but just to be clear, also check it with the this thing, the sheet that was already been provided to y'all, if not provided, because I had shared the solved sheet that we had solved on the other, when was it? Sunday, yeah. When we had solved it on Sunday, I had shared the sheet with all the pod leaders. If you all haven't received, just request them to share it with you all, which has already been shared in the pod leaders group.
What sheet is that?
The sheet we solved for module 1.
Okay, okay.
T-test is used in place of, can be used in place of chi-square test, right?
Not really, because with chi-square, we are testing if the data fits the model and it's if the variables are independent or not within the given data.
Okay.
And
But
for T,
in,
yeah,
but in that module, there was a point that it can be used as a substitute for t-test. Was it Wilcoxon or a chi-square test?
That was for a two sample t-test. This is a one sample t-test, hence we also have one tailed test.
Okay. So for two sample
Okay.
t-test, it is used as substitute for Wilcoxon, right?
Yeah.
Yeah. Yeah. T-test is an alternative for Wilcoxon test.
Just to clarify, Yog,
Yeah.
chi-square test and t-test for accepting the conditions, it's totally alternative, right? Because for for t-test over here, like our t statistic was lower than our critical value, and we rejected null hypothesis. While in chi-square, we accept null hypothesis.
In chi-square we accept, and t, yeah, same.
Okay.
But you on that day we did a correction that if our test statistic is greater than critical value, then we will reject null hypothesis.
Yoga, I think you explain it once more. That a hypothesis thing.
Okay, wait. Let me pull up that sheet again.
Fine.
Which one module one?
For the chi-square and the Wilcoxon.
Yeah. See, for chi-square and for chi-square and for t-test, when our test statistic is greater than our critical value, we reject the null hypothesis.
Yes.
And okay. Can we move on to the next term?
Yes, yes.
Yes.
So here we have been given that a business owner must decide between opening a new store, expanding an existing store, or launching an online platform. Estimated profits in thousands for best and worst case scenarios are so and so. So this is, I believe, the heart and soul of Module 4, the one in which I feel the maximum marks can be scored. The question has been given to us if the Hurwitz alpha is alpha the criterion that is set to 0.6, which option should the owner choose? Firstly, it's come to what decisions we are being given. So decisions, they are nothing but your acts or your courses of actions. Basically, they are your alternatives from which you have to choose. And the scenarios here, scenarios, they are your states of nature according to which the decisions are made. So suppose if you get the best profit in online platform, you go for that. If the worst profit you are getting, if you want to find out the best of the worst profit, or in which your worst profit is the minimum, then you would go for expansion. Stuff like that. With me so far, if anyone needs. an explanation again.
Yoga, I have a doubt. What is Hurwitz? Like over there, there's something that's set to 0.6 Hurwitz.
Yeah,
Hurwitz.
it's
I don't know
the
how to pronounce it.
yeah, no, even I do. So it's a Hurwitz criteria. It's basically it gives weightage to our options, to our best and the worst option. Here there are only two scenarios, but if there were more, they would have been given different weightages. But the weightages are only given to the best and the worst to choose from. So for and always remember
Yoke to the best and the worst what?
courses of action.
Courses of action.
See Hurwitz, this method is calculated on courses of action. Later. Hurwitz method, it's calculated on the courses of action. All of these which I'll be explaining, all of it is calculated on the courses of action. Only in one thing, the states of the nature get involved. So here our formula would be the A given into A of B. Okay, so now what is this payoff? Payoff is nothing but your earnings in all of these uh, within all of these alternatives and states of nature. कि अगर मैंने मेरा expansion पे best profit कितना होगा? So that would be 250. These are in estimated profits in thousands. So 250,000. ऐसे that is your payoff from choosing an alternative in a state of nature. Okay.
You in this question, best profit and worst profit are our scenarios, and new store expansion, etc. These are our decisions, right?
Yes.
Okay.
So we always choose from our decisions and from our alternatives. So hence, for new store, we'll find out what the expected payoff should be from the Hurwitz criteria. So here we have been given only two values. So one with the highest value is the maximum payoff, and which has been given more weightage. Weightage can also be equal, like if it was 0.5, then obviously it's equal weightage. If they were more conservative, then the we would have like something 0.3, 0.4 being multiplied with a maximum payoff just for a conservative approach. So it always depends from company to company, from industry to industry, how the weightage for any of the criteria would differ. So in this case, we would multiply 0.6 with the maximum in our case is 300 for the new store. We are first calculating our Hurwitz criteria for the new store. And then we would add 1 minus 0.6, multiply it with the minimum payoff of 3,000. So 0.6 into 300, that's 0.4 into 100. That would give us 180 plus 40, a total payoff of 200 from the from opening of a new store if that alternative is chosen. Then if we go for expansion, what would happen? So again, our criteria, a weightage to the maximum payoff, 250. We would add it with 0.4 times our minimum payoff, which is 120. So 150 plus 48, that would give us a total payoff of 198,000 in profits. Now we calculate for going online. So again, higher weightage to our maximum payoff, lower weightage to our minimum payoff. This would result in 250 plus 20, giving us the payoff as 260. So hence, this is the maximum payoff, and you can this is our Hurwitz criteria sum. Does anyone have a doubt?
I think you can proceed. So under decision tree, our criteria for selection of an alternative, it's EMV, called as expected monetary value. So it's nothing but again, this time instead of like in Hurwitz criteria, we had given weightage, but this time we use probabilities of individual events to get how much of our maximum payoff would be. So again, like Hurwitz, expected monetary value, it's calculated on our acts or courses of action, and we multiply the probability of the event with the expected value to get a expected monetary value, which is a more conservative approach again. EMV for supplier A, that would be 80% of 400,000 plus 20% of minus 100K. So now this thing should be kept in mind that if we have a negative value, suppose we have a loss here, so you should include the negative sign because all of these criteria that we calculate, it's for the payoff. It is for the profits and the earnings that we are gonna get. If we incur a loss, that's not really an income. We don't earn anything. Hence, you should always include a negative sign if there is a loss situation. In this case, it would be 320K plus minus 22. So this would give out a total expected monetary value of 300,000. Then we calculate the same thing for B. In this case, it would be 3% of 350K plus 10% of 50,000. So 3152 plus 5K. Given our total expected payoff of 3,10,000. Supplier B chosen.
Which suppliers to be chosen?
My bad. Supplier B should be chosen. No doubts, right?
No.
So this is the same kind of question, just in a different format. So a solar panel manufacturing plant performs quality inspection on every 500 panels of a batch before shipment. To ensure high quality standards, a random sample of 50 panels is selected for testing. They have a few defective rates and criteria. Like if the defective rate is below 2%, then the batch should be approved for shipment. If it's between 2 and 6%, then another test or further testing should be conducted, and that would have an additional cost on the company, which is 1,50,000. And if the defective rate is over 6%, then the batch should be rejected and scrapped out, the value for which would be 6 lakhs. We also have been given the probabilities. So that is an indicator if the probabilities have been given. It's an indicator that expected monetary value should be used. So a probability for less than 2% defective rate is 60% or 0.6. A probability for defective rate between 2 and 6% is 0.3. And for defective rate over 6%, the probability is 0.1. So we have to construct a decision tree to represent the possible outcomes. Decision tree is nothing but it's similar to a mind map. And I'm not going to draw that now because I don't expect that's going to be asked to us to draw a mind map in our exam, like term one's creativity paper. And we have also to calculate the EVM for the decision process, recommend whether the company should implement further testing or rely on sample inspection only. So again, EVM EVM by far, I think we are pretty clear that it's probability into the cost. Remember, it's for maximizing our profits and minimizing our cost. So EVM for so in this case, they are trying to find out what our cost would be for the entire process. That would mean we would multiply 0.6 into 0 and add it. We would multiply 0.3 with 1.5 lakhs and add it. And we would multiply 0.1 with 6 lakhs and add it. 0.6 to 0, 0.2 to 1 lakh 50, 0.1 into 6 lakh. So our EVM would turn out to be rupees 1 lakh 5,000. So here we can say that if like conducting a test would, if in any condition, if conducting a test with all of these criteria, if it exceeds the EVM, our expected monetary value of 1 lakh 5,000, we should change our policy or something like that. But since less than our current test cost and these can go forward with. Any doubt here?
So the answer is further testing should be recommended or for the third part?
So it should rely on the sample inspection because our
Okay,
EVM is
it's smaller. Yeah, okay.
okay. Now we have to conduct, we have to test the limits. So a logistic company monitors package delivery times to ensure on-time performance. They collect 20 daily samples, each consisting of 5 deliveries, and record the average delivery time and standard deviation per sample. From historical data, overall mean delivery time was
42 minutes, and overall standard deviation was found out to be 4 minutes. Using a control chart, we have to find out plus 3 and minus 3, plus and minus 3 times the sigma limit. So in this case, we are going to uh, find out the upper and lower limits to find out how much of the deviation that is there in our delivery time, how much of the what is our range for our delivery time. Here it has been given a mean delivery time of 42 minutes. So how much is it earlier and how late can our delivery be? That is what the upper and lower limit, that is what the use of the upper and lower limit would be in this case. So in this case, our n that would be 5 because we have our sample consists of 5 deliveries each. Because 20 daily samples, each consisting of 5 deliveries. That's why n is 5. People this our central limit. Our mean is our central limit. Then we calculate something called as standard error, which is nothing but your SD by root n. So in this case, it would be 4 divided by root of 5, which turns out to be approximately 1.789. Now coming to our limits. So this is our mean plus 3 times the standard error. So in this case, it would be 42 plus 3 times 1.789. That would give us a value of 47.37. N is equal to mean minus 3 times the standard error, which should be 42 minus 3 times 1.789. Should be 36.63. So for obviously we have to find the lower and the upper control limits. Hence for upper, we add the 3 times standard error, and for lower, we subtract it by 3 times the standard error or whatever the decision criteria may be asked in the questions. So ideally in your chart, you would have a mean line, which would the central limit line, which would be 42. The upper line,
the upper control line would be at 47.37 and the lower control line would be at 36.63.
Why N is 5 and not 20?
Because within each of these samples, there are 5 deliveries, right?
Okay.
And this is also for our 5 deliveries. Our mean and our standard deviation is given based on our set of 5 deliveries.
Okay.
Yog, I did not understand this control chart part. How do we construct that?
I don't have a diagram, but basically it would be a line chart or any of those charts. You would have a line passing through the middle. You would have a line passing through the middle, which would be the mean value. Suppose it's 42 here, then you would have a line going through the middle, which would be 40, which would have the value of 42, a value indicating 42. You would have a line somewhere on the top of the graph, the upper control limit line. It would be representing the value 47.37, and somewhere above the x-axis and on below the uh, central limit line, somewhere below the mean line, almost close to the lowest value would be a lower control limit line.
Okay.
Can you just solve this midterms? Second midterm is right there. So that's last question.
Can we do that after our sample paper discussion?
Yeah, sure. Yeah.
So this was all for explaining the concepts, except for the minimax, maximum, and maximax criteria. Except for that, our questions are done. We'll come to sample paper now. And for module 4, we have question 14, 15, 16, and 28, 29, and 30. So we cover those from sample paper. Here we have been given that a farmer must choose between 3 crop options with profits in thousands, dependent on the rainfall. So again, our app is crop and our sources states of nature at the rainfall. Here we have to use the max criterion. And I get it, it can be confusing what it means. So maximax is nothing but maximum of the maximum payoff from the app. So in this case, it would be the crops. So ideally, you could create a column like maximum and minimum. That would be really easy. Then for, as I said, it's for all of the criteria. It's for all of the apps, your courses of action or your alternative. So if you had to suppose plant a crop corn and some or the other type of rainfall, and soya bean there was there and wheat was an option. So suppose in drought, which should be a more profitable crop for a normal rainfall, which should be a most profitable crop, same for heavy rain. So that is what we choose in such cases. Maximum of the maximum payoffs from the assets. And our payoffs would come from which crop we sell, not under which type of rainfall we sell. Hence, if we had to find out the maximum for suppose corn, it would be 60. For soybean, it would be 50. And for wheat, it would be 40. You should consider the maximum value from any type of any state of nature. So we are getting 60 and 50 from normal. The 40 could for corn and soybean we are getting 60 and 50 respectively from normal type of rainfall. But for wheat we could get 40 also from drought and from a normal type of rainfall. Drought is I know no rainfall and all, but any which ways it can come from any of these states of nature. Hence, we want to find out the maximum from where we can get the payoff or profits in this case. Here it comes from corn. For corn, it is 60. For soybean, it's 50. For wheat, it's 40. So since our maximum profit comes from corn, we should go with A. If the farmer uses Maximax criterion, which crop will they choose? They would choose corn, which is A. Any doubts? So using the same crop profit table from above, assume the farmer's optimism coefficient for alpha is 0.7, which crop maximizes Hurwitz weighted payoff. So yeah, this A for Hurwitz criterion, it can also be called as optimism coefficient. So you should be careful when they use it interchangeably and which method to use. So again, as Hurwitz criteria is followed on the courses of action or our alternatives, we calculate it first for corn, and this time the weightage for our best profit is given as 0.7. So uh, 0.
Could you explain what is optimism coefficient once more?
So remember I said Hurwitz, it provides like basically a weightage to your best and the worst payoffs.
Yeah, yeah.
Payoff. So yeah, whatever weightage you provide to that, your condition, your best condition, that's given as optimism coefficient. So for corn, it would be 0.7 into the best payoff from corn is 60. And 1 minus 0.7 into the minimum payoff is 20. So corn would give us basically a payoff of 48,000 uh, yeah, dollars in this case. Now we'll calculate the same thing for soybean will be 0.7 into the best cases 50 plus 0.3 into 30 5 plus 9. The payoff from soybean is $44,000 and our last option B and our last so the payoff from B would give us $34,000. So again, if we see the maximum payoff is coming from corn, hence using the Hurwitz weighted payoff as well, corn A maximizes the profits for the farmer. Ideally, if in a question, for suppose this question also had mini-min and maxi-min criterions, ideally most of the criteria should give out one value.
Can you solve it through min max?
So we did maxi-max, right? We did maxi-max and we did forward. So maxi-min. So this is maximum of the minimum payoffs on the of crops here. Yeah. So the minimum payoff for corn is 20. The minimum payoff from soya bean is 30. And the minimum payoff from wheat is 20 again. So since we are looking at a more conservative, but an approach that would uh, not give us profits, we do get some profit, and which is ideal in an optimistic range. We have soybean, the maximum of the minimum payoffs. So that if we are a little aggressive, like with the maxi max, it's very optimistic, it's kind of aggressive as well. Hence, we use maxi min, from which we get maximum of the minimum payoffs that we expect from selling such crops. Here it's soya bean. So if the question was if the farmer uses maxi min criterion instead of maxi max, if the farmer used maxi min criterion, the answer would have been soya bean. It can always differ, but if it's the same, then it's a very good payoff table. It's a very good matrix for whoever has it. Then we had mini. So it minimizes the maximum opportunity loss. So what do I mean by opportunity loss here? It's like if I went on to produce, firstly, opportunity loss that is calculated on a states of nature first, and then it is calculated for our acts or for our courses of action. So if we conduct an activity under normal rainfall, what would be a opportunity loss for conducting and sorry, let me go back. For opportunity loss under a state of nature, we subtract the all the values from the maximum payoff. So for normal, we would subtract 60 from 60, 50 from 60, and 40 also from 60. So it would give us the idea if we don't go for this alternative in so if we don't go for other crops in normal rainfall, what should be our loss of profit for doing that? So um, so for drought, the maximum payoff comes from selling wheat. So we subtract 20 from 40, 30 from 40, and 40 from 40. Then for normal, a maximum payoff comes from corn. So we use corn as a base and subtract all the other values from it. And for heavy rain, it's corn again. So 40 minus 40, 1, 3 minus 20. So here we would get the value as 20, 10, 0. We get 0, 10, same thing as 0, 10, and 20. Then again, we calculate the maximum opportunity loss. So this table that we create for the minimax criterion is called the regret or opportunity loss table. Then we calculated the value based on the states of nature. Then we again come back to our acts. Here it's crops for us. And we find out the maximum opportunity loss. So it's 20 in this case, 10 in this case, 20 again in this case. And for minimax criterion, it was minimum of the maximum opportunity losses. So that would be soya bean for us at 10,000 in opportunity loss. So if somewhere you get a value as here we subtracted the maximum value from the other values, right? If in some place there was a criteria set and anywhere if you get a value as negative, suppose if you had negative 10 here, then you have been wrong somewhere. Some calculation errors have arise, that's why. Otherwise, you should get the all the values as positive. Does that answer? Guys, this is another expected monetary value question. We have already done two of these, one with a very similar uh, story. Do you want me to do this again?
No, I think we can do this.
Okay. Then we have last three questions. These are the MCQs. So the Hurwitz method, it combines basically your minimum and maximum criterion or your optimism and pessimism weights, only probabilities of outcomes, historical averages, none of the above. So for probabilities, we know it is expected monetary values. Historical averages, they are not basically needed until you are doing some tests. Okay, now optimism and pessimism weights. It doesn't combine these. These are the already criteria given to us. So it only combines minimum and maximum, minimax and maximax criteria by giving us the payoffs. Because in minimax, we get the minimum of the maximum payoffs, which is your literally 1 minus A weight, and maximax as what you multiply with the optimism weight. And question 28, answer is A. And for question 30, so in question 29, a decision tree splits data based on random selection of features, criteria that maximize information gain or purity, linear regression coefficients, control chart thresholds, none of the above. So we know control chart thresholds, there's a separate section for that. There's a separate sum and criteria for solving control chart thresholds. Regression coefficients, we nowhere saw that in our decision tree question here. And these aren't a random selection. Here, this wasn't randomly done. It was analyzed that from choosing supplier A, the profit would be 400,000 with 80% probability and 100,000 in losses, 20% chance of that. So something similar for supplier B. Hence, not random. It's a criteria that maximizes information gain or purity. Because we calculated EVM, 80% of 400K, 20% of 100K, then 90% of 350, 10% of 5, our total EVM from supplier A and B, and then we made a decision. Hence, it is a criteria that maximizes information gain or purity. The value is, and for 30, the maximin criterion is used by a decision maker seeks the highest possible payoff regardless of risk, focuses on minimizing the maximum possible loss, balances optimism and pessimism using a coefficient, ignores probabilities of outcomes, assign weights, and then take the maximum payoff value. Okay, so even was Hurwitz ignores probability of outcomes. Here we do not ignore it, we just haven't been given, so we can't say anything about probabilities, hence ignoring is out of the options. Balancing optimism and pessimism using a coefficient, it's the optimism coefficient of Hurwitz, which had been given to us earlier, and focuses on minimizing the maximum possible loss. That is what we just did in Minimax. So it should be A. Seeks the highest possible payoff regardless of risk. Ideally, the answer should be none of the above. What's the answer given for this in the sample paper, Harshit or Rishabh? Can you check? Hello.
Yeah, we can hear you here.
Yeah, can you tell me what's the answer given in the sample paper for this? Because none of these are right.
For question 30, it is option B.
E. And that is the minimax criteria, not the maximum. Anyways, I've attached what maximum should be and the answers for the previous two and other questions. If anyone has any doubt in any question,
I don't think anybody does.
then I think we can end the session.
I just had a doubt, right? Like I just said you to solve this midterm two's last question.
So yeah, sorry.
Yeah.
Let me see now. Three.
Yog,
Yes.
I think let others leave if they want, right?
Okay.
At 6 we have another session, right?
Yeah.
Right.
You just one thing. After this session, is there anything more we need to do from the modules, like data given on the website, or this much is fine?
I mean, you should go through it if you have doubts. And
Like
like
you have
some,
basically covered all the topics, right? Or is some topic which is still left to be covered?
no, it's all fine.
Okay, fine.
Okay, can you see the screen? I'll put the question. Hello.
Yes, we can see it.
Sorry, this is the wrong question, right?
This is the last question for me.
No. Just give me a sec.
Okay. Then just tell me the question then.
Yeah, that's what I'm looking to. Wait.